Hi, Jürgen. Welcome back.
Hi, Adam. Thanks for having me back.
Yeah, and today, Mission Impossible. So you would like to explain me or convince me that OSGi is usable and can be used to structure applications, right?
Yes. So, not sure if I can convince you, but I know that it is possible.
And the last time, I also noticed that you are the chair of the OSGi working group. So you are at least OSGi believer, I would say, right?
Yes, you can call me an evangelist.
Evangelist,
like.
okay.
Evangelist.
An OSGi evangelist.
Yeah, so I came into office last year as our former OSGi Alliance president, and then the OSGi chair went into well-earned retirement. Yeah, so I stepped up, and everybody seemed to believe that I could make a good job as a chair, and so now I'm the chair.
Okay. So before we start with OSGi, the first question we should ask ourselves is why we need a module. So I would say this is what or a component or module, whatever it is. So we already had here at the podcast conversation about modules, and what we found out that there is like a physical modules and logical modules. So you can have something on the disk like a jar, or you can have something in your code like a package. I'm more interested in the packages and less in the jars because of the deployment model simply. And what I see less than, I would say nowadays is a little bit less common, but developers really loved modules. So I saw lots of modules in all variations, and so now the question to you is why we should use modules at all? How many of modules, and how you pick the perfect module?
First of all, good question. To your first part, why do we need modules? The first thing is because we are not alone in the world. So usually we already have all kinds of modules in Java in all kinds of programming languages. So you have your libraries, and the library is usually a module. You're working thus with modules in the form of in C with DLLs, in Java with other jars and other frameworks, and some kind of dependencies, and each dependency is a module. So we already have this. Even a Java class itself is a small module.
Yeah.
So
but from pragmatic point of view, I see what you are saying. But I am a couple of Java SE projects with Maven, so there are no dependencies. So I'm perfectly happy with Java SE 11 and 17, and except JUnit, I really don't have any dependencies. I have some tools which are not that small, bigger. The question is why I should care about modules then?
Because, as you say, even if you don't use that many external dependencies, I guess you are independently of this are writing applications for Tomcats, applications for enterprise servers or things like that. So thus you have dependencies to at
not
least
even
the
this.
application container.
Let's imagine we would create together a let's see a CSV parser for to find out how popular an podcast episode was. And this would be a command line tool with Java SE. And even I would write it alone. Should I care about modules or not?
Yes. Okay. So let's bring it to the point of modules. It's very likely that you have external dependencies in whatever shape, kind of form. So this is something which is clear. So in your example, you could write your command line things by just implementing a main method and doing everything, or you try to think like, okay, there are convenient tools like I know about Pico CLI, which is this neat little tool to write these dependencies. So you already have your first dependency there. When you do this, let's step a bit back to the pre-Maven times. You may remember most people had an end build most likely, and all your dependencies had been somewhere on a shared. Either you've checked it into your SVN or whatever had been used at the time, or CVS, or you had it somewhere in most companies on a shared folder or something like this. Everybody was relying to. So this was always a bit cumbersome because you manually had to curate what you are using down there. So then Maven came around, and with the Maven repositories, they already had this dependency management in there. So you say, okay, I use my Pico CLI, and whatever the transient dependencies Pico CLI has is in there. And you also have the possibility in Maven to say, hey, these are compile time dependencies, these are runtime dependencies. So it is useful for packaging in the end. So, but this is only at build time. At runtime, you have no way to enforce that your dependencies are really there. So if you are in luck, you are building, and the developers of the underlying framework, of the underlying dependencies put in their scopes correctly. So if you say, for example, Maven package the WAR file for me or the EAR file, then everything is packaged correctly for you. So this is already a necessity for having a module. And by the way, the definition of a module is not just a module. A module always needs a contract. So in order to work right. So a module should state what it requires to work and interact with the world.
Okay.
So this is something Maven already does, or most builds somehow do. The POM.XML defines this quite nicely, but this is only at build time. So, it's never really an enforcement or a guarantee that this is also working correctly at runtime. So this is where a module comes in and is useful if you can define these contracts at runtime as well.
That's interesting because, I see where you're going, and you are absolutely right. But we have absolute different priorities. So for me, like Maven or Ant back then with Untask and the jars and Maven is just plumbing. I use Maven because I have to, right? So I whether Maven pulls modules or not, I don't care. So for me, actually, would be the best possible case if Maven will pull one single huge jar with everything inside, and I would just use it. This would be my perfect world as a developer. It doesn't work that way, I know, but for me, from the usability perspective, would be the best choice. So what happened to me in all my Java SE tools first, I mean, War even more, but even in Java SE, if they get a little bit larger, I always get two parts of the app. One part is stable. It doesn't change frequently. And there is always some part which changes frequently. And regardless of the contracts, what I always try to do, to package the moving part somewhere else. And this is usually Java package. So then if I open, my project, I know, again, I will have to change something. So I go to this package and change it. And I know that everything else is unchanged. So for me, it is like module, maybe it's a wrong term, but I use module to, divide and conquer. To break a huge system into little parts. And these parts are, whether they have contracts or not, I don't care. I need a namespace, maybe, right? So what I would like is a nice name, and everything is inside. So if I open the thing, I know, okay, this is like my, our podcast rating app or whatever, and this is what I care about.
Yeah, which is totally understandable, and this is how everybody actually, mostly uses modules. But as you say, you already have two different parts, meaning you have two kinds of modules. So, so to speak.
But my modules are more like the language features and not the build features. So for me, it's not that about build time, and I also don't care whether the modules are really independent or not in the first iteration. What I really care about is that if I open my package, so like cohesion, so everything which is in the package belongs together because I don't have to look at the entire thing. I would like to have smaller, nicer packages with nicer names. So this is what I care about.
Yeah, which is totally fine. And the difference becomes, the question usually is, how do you cut your modules when you have modules?
Exactly.
So this is, there are a couple of best practices, but there are a lot of different ways. So some try to, as you say, you do it in the way you have described. Others do it in a kind of cut it in a business fashion. So every business operation is in their module, whatever the module however they structure their modules by packages or by jars. So there are a couple of different ways. And actually you never get it right in the first place. So usually, things change over time.
But what I saw, which doesn't work really well, is trying to create modules as technical layers or something, where people suspected that the database is going to be replaced, so we get DAOs in one reusable layers or whatever. I would say the likelihood is so low that something will change there.
I'm totally with you. People tend to, there are kind of two kinds of developers. The one thing is the more practical developer who just throws everything together, broadly speaking, so it works. And the other thing is the over-engineer.
Yeah.
So, and that's usually the thing. There are some things, are very unlikely to happen. So, but projects progress and teams get larger. Murphy kicks in, and everything which is possible will be done at some point in the future. So this is where a good modular system kicks in. It makes such things refactoring friendly and helps you do such changes, and also kicks you in the ass just upfront when you do things that will bite you later on.
Okay,
so this is what it is, and as bigger, as larger and as longer running projects are, the more likely it is that some changes will appear, that somebody changes the database underneath it. So it's just, if you for your, you and your friend project, this is unlikely, but if you have a team with hundreds of developers, for example, then things like this will become more likely.
Yes. So this is true. But just another discussion whether you can be effective in a team of 100 developers, right? I would like to split this entire thing into smaller teams which are work independently. This would be my next attempt. So, but let's keep it a little bit later. So, what's your way of cutting modules? So, what are you preferring? It depends. Not an answer.
The thing is, I have a few best practice, as we are over time became more fine-grained with the modules, out of a relatively simple reason. In OSGi, we have the B&D tools we are using for developing the whole things. It allows you to run your application in your IDE, and every time you hit save, it redeploys the parts of your application that have changed. And you never need to restart. And this automatically leads you to the parts where this takes a long time because your modules are too big, because then the whole cascade of all your services are going away. Your services come back. You have something which builds an index, which takes 20 seconds. Then you move these parts automatically out to own modules that are independent of the others. So they don't need to be rewired all the time, restarted all the time, the index rebuilt, and so on and so forth. So you quite naturally progress to a reasonable kind of modularization along your development progress. So this does not necessarily need to have a big influence at runtime, because at runtime nobody really exchanges or rarely exchanges singular modules all the time. Some projects do, but most projects just are deployed as a whole, as a blob. But at development time, it really saves you time. So, because if you never need to restart the application, and thus, it mostly progresses along these lines.
Okay, so you start with a monolith, and then you break it down because of pragmatic reasons. So you observe how it behaves, and as long as you are productive, you are happy.
Yeah, something like this. So over time, then you before you start breaking things apart while you are developing, you just start out with a module because I have my my business case, so to speak, with, let's say we stick to the CSV exporter. So there would be a module which contains the CSV exporter, maybe another module which just contains the API. So, and then you have the other module which then is using the CSV exporter. So you can, in theory, take the CSV exporter, throw it in another project and be fine with it and use it as it is. So this is just things that then are, habit.
In my mental model, if I would write, the podcast app, the CSV exporter would be, or importer, however, would be a small detail. And for me, I would get a module for sure, podcast episodes or guests or stats. So this would be my first, attempts to create modules with this name, like, statistics, guests, episodes, podcasts, whatever. And the CSV would start in a first such a business package, and then the other components would pick, the exporter or importer. And in one point of time, if I would say, okay, it is useful and other project, or it will grow the exporter, then I will extract it afterwards to a standalone module. So I starting, with objects. So for me, it's like, for me, a package in Java is more like a Java class, but it's bigger. So I'm thinking in modules as Java classes with responsibilities, and business is not even business. It's like what we are building, right? We started at university with I think vehicles, ships, and airplanes, whatever. So this would be my first idea. A package would be a vehicle or something like that. And the CSV exporter or logger or cache or configurator, this is hidden. This is just the cross-cutting concerns. They are not on the top level. So if they grow bigger, then I will extract it to a top level configuration project. But it is not like, I don't like to emphasize the technical stuff.
Yeah, and this is something which especially in OSGi, you don't need to do, because the smallest module in this sense is the package.
Yeah.
So you can move your packages around between your jars and your bundles, and the system as a whole doesn't care about it.
This is what I like.
So this is what you can do at any time. You can even, what we are doing from time to time is just repackaging packages from one jar to another. So because we know at deployment time, we just want to have this one jar which contains a few bundles or a few packages in there, and at runtime it doesn't really care, because if you do OSGi right, then you just have you have your manifest in your module which states which.
Stop with the OSGi. I would like to stay a little bit longer with the modules itself, and then cover really deep OSGi.
Yeah.
Because what he also said is the huge project with 100 developers. So my attempt would be to split such a project with 100 developers into 20 projects with 5 developers, if possible. And this would be the challenge, and every team would be independent, and we would have one physical package, let's say WAR or whatever, jar, Quarkus or WAR application servers, and they would create 5 developers such a WAR. This would be on team. This would be the challenge if I really have, to deal with that big teams. And then within such a WAR, this is what I'm thinking about packages. So the team would create, the business packages. And regarding OSGi, what you said is not like, I don't like to have too many packages at the top level. So they are coarser from business responsibilities. Yeah, if you look at Amazon, this would be like shopping cart, products, shipments, or whatever Amazon comprises, but not necessarily, string utils or whatever. I don't care about that. So then I would like to try to hide it somewhere else, so that it is not relevant to my business logic to know that we have CSV exporter, let's say, right, or a serializer, or persistence, or JPA, or whatever. This is what.
This is exactly what modules should be about. Abstracting all these things away, that you as a developer, you just work with packages basically.
Okay.
So, and yes, at development time, you have your build dependencies where I say, hey, I have my convenient repositories where all these things are in there, where they are coming from. This is something you should not really must have the need to take care about these things. So you should have tooling which then takes care of these things for you.
Okay. So cool. So now towards OSGi. So the first thing what I like, you told me, one package is a bundle or a module, which is great because it just works. What we are talking about now, there are different OSGi specifications. So which specification would I choose if I would like to have such a module system?
That is basically the core specification.
Okay.
So the core specification just defines, hey, there is a framework. A framework is something that can have modules installed, and modules consist of a couple of packages. So, and the framework at runtime is responsible to puzzling together who gets which package in which version. So, because you can have versions as well, or it is a good idea to have versions as well at a certain point.
And how to specify the versions? So how can say my package is in the version 1?
You have different opportunities when you have the right tooling. So the one is you have your, if you don't give a specific version, I believe we always give it the tooling always gives it your bundle version. Also bundle is the jar it contains. So this is version, and if this is version 2.0, all your packages will get this version.
So from manifest, right? So it reads from manifest for a manifest MF.
Yes, also we have the tooling which creates the manifest for you. You don't have to do all these things manually. You just have to define somewhere, hey, this is now like your Maven. In Maven, you set your version already, and this is then also put on the packages. Or you can also choose to individually version your packages by slapping an annotation in the packaging.
This is good.
Class.
So it means it picks from the jar, but I don't like too much magic. So I could use my jar tool from JDK. So then I will create the Java classes without any version information. Then I could still use annotation and say, okay, this annotation, the bundle is version 2. Will still work.
Yes, also you would need to have some build tooling around it. So nowadays we have there are a couple of different ways to develop the whole thing. We have a vanilla Maven way with Maven plugins, which is you just do your normal Maven development, and then it goes over your compiled classes, looks for annotations, looks for whatever else things we need, and then with this you can it then modifies your manifest with all the things given in your POM. And together with what's in your annotations. And all these annotations are, by the way, only compile time annotations. They aren't around and clutter up your runtime.
Yeah, very good.
Things.
So, but let's say I would like to create a Hello World module. So the simplest possible Hello World OSGi module with the least possible tooling involved. Let's say I only have VI.
In Maven, in Maven, for example, you just set up your normal Maven build and add the BND Maven plugin. And
what happens behind the scenes? Why I need a plugin?
What a plugin does is Maven normally compiles your triggers the compile of your code, and then the BND tool, the BND plugin goes over your compiled classes, looks which imports you are using. Which things, when you need to slap an annotation above it to say, this is some API I want to export. So you can control which packages are seen from the outside world, from outside your module. So you can control this, and it would also look at, hey, have you defined some versions for it? And then it would write the manifest for you. So there's nothing you need to do. So
but I need the manifest. So the manifest is what's needed. So I could, if I would be, skilled writer, I could write the manifest by hand. Yeah, right.
You could do this by hand, and this is what other build tools are, also like the PDE, which you use for Eclipse RCP. Yeah. It is manually writing the manifest, but nowadays, also it isn't possible. I would say it's not humanly possible to write a good manifest for OSGi by hand, because. It's looking what you are importing. It's also looking what other things you are using and stating all these things in there. So later a resolver could come around and dynamically and find out what dependencies you would need out of a big set of dependencies you provide for it.
But it should be technically possible to not have the manifest MF and just read at runtime the annotations, right? I mean, this should
because they aren't available at runtime. These are only compiled.
Yeah, but I mean, this is the limitation. But we could make in, the retention runtime, and then it could be possible, should be possible to have OSGi without manifest, right?
Could be.
I mean, the idea would be even.
Yeah, the question would be why, because this is something which never changes. So
but if you think about this, I mean, the penalty is low, but you wouldn't have to maintain any tools.
Yeah, this is one thing OSGi is all about, is keep your dependencies as minimal as possible. So all the things if you have an OSGi bundle, which is done in a proper way, then you would not have any OSGi specific dependencies in there. If you do it right.
Yeah, but this is like
Java as well.
Yeah, I get you, but I mean, I would say I have nothing against an annotation, right? If I say, okay, if I'm happy with the OSGi annotation in my bytecode, then it would be less magic.
Yeah, it would be as much magic as it would be before, because then somebody has to do it at runtime, what we are currently doing at compile time. So, and also you have always at runtime this thing that somebody needs to get around. Look at each and every class you have. Maybe there is an annotation on there, maybe not. So somebody needs to know about every other class, and this is also a thing what modules are about. In the module system, this isn't really possible. You can't look at every class if you don't declare that you want to look at these classes. So this is the reason why things like JPA and all these things that use code weaving have a hard time with the Jigsaw and JPMS stuff as well.
Yeah.
So because they want to look at every class and add something to it, maybe or not. So this is why we decided years ago that this is better to do at build time.
Yeah, no,
so because
this is also a good decision because this is what also Quarkus does. I don't know whether you're aware of Quarkus. What Quarkus does, it looks at the annotation at build time and generates the bytecode at build time, which is
yes.
But the other idea would be what I just a question whether there is such a thing, because this is what application servers are doing. They're looking at runtime at all the annotations, and building the like you said JPA. So it should be possible. There are different trade-offs, but you don't need any build time tooling. For instance, Quarkus, right, also requires a plugin which does the building, not manifest but bytecode. But like Payara doesn't have such a plugin, and it just does it at deploy time. So this is two possibilities.
The thing is, one of the reasons why we are doing it this way is with this information in the manifest, we can assemble what is required at runtime without looking at bytecode, reading annotations, and things like this. Meaning, staying to how modern OSGi works. Let's say I want to write a REST API for whatever. So with JAX-RS, we have a thing called the JAX-RS whiteboard where you can register your. It's like JAX-RS roughly. So what I do, I write my module. As I say, we call it bundle. I write my bundle, have my few REST endpoints in there, just a hello world REST endpoint, for example. The build tooling comes around, looks at the annotations, writes the manifest. So then I have my module, which just contains some REST resources. So then at a certain point, I want to say, hey, now I want to run the whole thing. And then we have something that's called the resolver. And the resolver, you just give it the bundles you think are necessary. In this case, my REST bundle. And then it looks at the manifest and says, okay, somebody tells me here he wants JAX-RS, so I need somebody who provides functionality for JAX-RS. Then he looks through all the dependencies you give him, which are usually somewhere in your build path. And then it figures out, okay, here is my JAX-RS implementation. Oh, JAX-RS implementation, this requires a servlet container. So it looks through, here's a Jetty, for example. And then uses only the things and packages only the things it really, really requires. So, and nothing else around it, which comes to the point, we have, as an example, do you know about Vardin?
Vardin, yeah, sure. Hello.
Yeah, we have a so-called Vardin whiteboard where you can register your Vardin things. And we have the standard demo, which Vardin is using as well. It's normally built with Spring. And the result of the Spring build is 45 megabyte, if I'm not with Spring Boot. And the same thing with the OSGi build is just 15 megabytes.
Okay.
So, because it only takes what is really, really necessary. So, and this is what you can do if the things are stated correctly in the manifest.
Does it also start faster than in Spring Boot, or?
I've never really measured it.
Because this would be interesting.
As it has to load less things, I would assume that it might be faster as well.
Okay.
And this is the nice thing. For OSGi, you never need a runtime in the sense like an application server around it, which comes of a lot of things you usually don't need, or a Tomcat or things like this. So it's if you do a vanilla OSGi build, then you just have in your final build result what you actually need.
Okay.
So there are different exporters. You can a self-executable jar comes out of it with only the few bundles in there that are really, really necessary. So that's the nice thing about it.
But in theory, I could also use package info for metadata, right? I just are thinking,
we are using it in parts. So, for example, the export, as if you declare an export for a package via an annotation, you do it in the package info.
Okay.
So, but this is the reason basically why we said we write all these things in the manifest. And on the other hand, most of the concepts predate, I'm not sure when annotations came around, but OSGi started as the Alliance in 1999. So
yeah, and before actually, I think OSGi Alliance, right? And before was OSGi. There was the book from Sun Microsystems. Sun started OSGi, and this was my very first, OSGi project where we did some experiments with OSGi. And I forgot there was some Sun embedded OSGi server. This was the name, something like this. Sun embedded server. There's also a book about that, and we did some experiments back then. And so it was really old. I mean, it is older than everything else. So back then there was annotations came in Java 5. So it is like, I don't know, 6 years after OSGi inception.
I know that the basic idea behind OSGi, so the alliance itself was founded in 1999. The idea is like 25 years old. So, and I believe Peter Kreens came up with the whole thing way back when. Then the alliance formed around it was a big thing at the time. But then it became a bit political over time, and I guess this was. There was once even an OSGi phone. I've got told. So until Android came around and just bought the whole store, and but that's another story.
Yeah, but just trying to understand the manifest MF, because I don't like tooling that. I don't like. This is what what happens behind the scenes usually at build time. For me, it would be also nice, to be able to annotate just the package info and have a module, right, without manifest.
Yeah, that's what you actually do.
Yeah,
in OSGi. So you can.
But package info to Java, the Java class, right? The package.
Yeah, the Java class. You write it on the Java class. You can say at export and then at version and then have everything in there. But
perfect. So this is what I search for. This is because I know the manifest MF and with the really strict formatting. And package info. This is what I also saw, I think, on Open Liberty. But so I could just write the package info and I'm done, right?
And in 99% of the cases, this would be sufficient. So it's rare that you have to put in. Also, I haven't touched a manifest itself in years.
Yeah.
So it may be that I give some additional configuration for the BND Maven plugin to amend whatever I'm writing as a word, what it's generating automatically, because tooling can only go so far. Always, it can make guesses, but, for example, if I say, hey, this import is there in my bytecode, but hey, nobody cares about it. This is strictly optional. Then you can tell there, okay, this package import, just make it optional or just ignore it.
Yeah.
So this is things you can additionally put on top of it if the generated things.
So in the core spec, we have resolver, and the job of the resolver is to walk through all the modules, and the modules are exporting capabilities and requiring capabilities. So if a module requires a capability, so the resolver searches in a cache or somewhere and says, okay, I know someone who provides this contract, and the contract is implemented by something internally. This is hidden. We don't know about what. So the modules becomes replaceable. And what we get for free, my understanding, is like a tree shaking. So only these modules are used actually, which are needed. Even if there are more modules on disk, they are just dead. They are there, but are actually not used because no one requires them to be started, right?
In parts, these are two things you throw together there. The resolver runs can be run at build time. Yeah. This was what I was explaining earlier. And then independently of this, at some point, there will be the start of the OSGi framework, and somebody would have gotten around saying, hey, these are the modules I want to install in there. Then these modules can have a life cycle, they have a life cycle. By default, they are all started after they are installed, and before they can get started, the framework tries to resolve what's in the manifest. So in theory, if somebody comes around, wants to load a class out of it, it can say, hey, I can provide everything which is required here. So these are the two stages, basically. So you have the build time resolving if you'd like, or you can do it manually and curate what you will put in there. But the framework will then validate this at runtime.
Exactly.
And this is also, for example, the recent Log4j thing that came up. This is what showed me where the strength of this lies, because everybody was panicking and running around looking through his projects, who is using Log4j in this version, and so on and so forth. And for example, if you would be developing, or if I would develop an EAR application as an enterprise application for a customer, then I would look through my application setup. Do I use Log4j there? No, I don't. or I update my dependencies, then I have my EAR or WAR file or whatever gets deployed. And then somebody at the deployment team at some point in the past would have copied an older version of Log4j in the common libraries of the application server. So, and then I would basically be screwed because usually it was always delegating to the parent class loader. And then I would get the old Log4j, even if I never have it somewhere in the parts where I have my hands on. And with OSGi, you would declare, hey, I want version XYZ, and then you would get it. If it would not be there, then it wouldn't work. So this is something you would get with this as well. So because there are always parts of your application you can't control.
Yeah.
So with this, you get some way of control over things like this.
Yeah, if you would copy this to the application server to the root, yes, sure. I mean, this is like JDBC driver, then it is just loaded before the application. This is like the hierarchical model. In modern runtime, like the newer runtimes like Helidon or Quarkus, there is only one class loader, so there is no more distinction between application server code and the app code. What you can also do, I saw this in a project, you can also load OSGi modules lazily, right? So you can declare in code, say, I would like to have a lazy load of this module. So if the first module is initialized, the other is going to be loaded on demand. So this is what I...
Yeah, no, not really. Some people mix this up a bit.
In annotation. So there is an annotation where you can say...
Yes, this is the component. What
exactly. But this is no more core, right? This is no more core. So the core specification we are done. What is the lifecycle resolution?
There's one additional thing to the core specification. What OSGi defines is it says, okay, you have now we discussed about the modules. So this is the logical separation of your classes, so to speak. And then they say, okay, if they want to interact with each other, okay, you can export and import your packages. So you have your class path exposed. But the other thing is they communicate via services. So, and the service is simply just some kind of a Java object which can be required like CDI and get injected and things like this. So in the core, they just say what we have here is a service registry where you can register your Java object and give it some properties. And somebody else can dynamically listen to this and query this registry. So this is what the core says.
Okay.
And the idea is you always export like an API interface package, a package which only contains the interfaces, and then somebody comes around and registers under this interface an implementation. So whoever uses it just works against the API and never has to know about the actual implementation detail underneath it. And it also allows you to have multiple implementations of the same interface, and you can distinguish between it because you can query the service properties and say, please give me the payment provider with the type property PayPal or something like this.
Okay.
So you would get the payment provider and it's PayPal underneath, or it can be Visa or whatever. So
it's almost like a qualifier where you can say,
something like this. So this is what the core specification says. And to make all these things comfortable, because when you do this manually, you can do this all manually, but this is a bit cumbersome to work with. We have the so-called declarative services, which is the component model, which says, okay, I can have my Java class, slap this component annotation on it, and then your class suddenly gets a life cycle. So it looks, when declarative services detects something like this, it just instantiates your class. And if you say, hey, I have an activate part, so when I become active, then please do this. Before I get destroyed or get deactivated, please do this. So it's another annotation you put on your methods. And you can also declare dependencies to other services. Let's say, please give me I need the CSV importer. Then my service only gets activated when the CSV exporter is there and active and activated. And so that's basically what the component model does. And this is also by default lazy. This means if nobody is around using the CSV exporter is never instantiated.
Okay.
So the first time somebody comes around, by default, then it is instantiated.
Who cares about the annotation? So if I have the component annotation, who is in charge of searching for the annotations? They have to be in registry. I guess this is the capability of the registry, right, of the service.
In this case, this is also something which the tooling does. These are only also compile time. This is the same module, the same plugin which does the whole thing for Maven or Gradle. It looks at this annotations and creates basically an XML file in your bundle. And declares in the manifest that you need a requirement to handle these declarative services, and states where these XMLs are in the manifest. So, and then you have another bundle in your framework and runtime, which knows about these things, looks at all the bundles that are coming in, looks in the manifest, says, here's somebody who's participating, and provides service XMLs for me, and then it reads this. So but something you never need to look at.
But if OSGi were a clean framework, the idea would be that in the service registry there would be a specific component which does the component scanning, right? So we have the core model. And on the top of that would be the component model. And this is just an ordinary dependency in the service registry, which searches for the XML files or the metadata or whatever. So the lifecycle module, this is what the container, how to call it, component container, how you call it, container runtime, should be actually just another service registry member, or how to call it.
It's using this. That's the nice thing. It uses the same service registry underneath because it takes care. It knows about the lifecycle of your components, and then when you can decide by implementing an API or declaring that you want to export a service, then it would register this in the service registry. And somebody else could use it by either manually, by querying the service registry, or declarative services uses this to inject it in your framework. And the nice thing about this, as it only uses the same service registry, we also have a CDI implementation, where you can use CDI next to it, have a clear bundle which uses CDI for injecting all these things and taking care of this. And it also works against the service registry underneath it, meaning you can have manually registered services injected in your CDI, DS, also declarative services in there that are getting injected in there without knowing in which way they have been implemented in the first place. So you can have a mix of all these things without caring about, has somebody used CDI for it, has somebody used declarative services for it, or has somebody done this manually.
So then I get it. So this is not like the service registry is the active component, it's more like the component spec is what is started, and it uses behind the scene the service registry. It's more like layering, right? So,
exactly.
Very good.
That's how it is.
Okay, this makes sense, because then the components are starting and they are using internally the service registry for the entire resolution. So, can you just start the core part? No, you will need something else, right? It doesn't make any sense.
The core part is always the framework. The framework is what you're starting with. It's either usually Equinox or Felix. These are the two main implementations. It's relatively small jars.
Yeah, but then how? I mean, if you always start the core framework, then all the services in the registry are started and they are done. But who starts the component part?
This is, like I said, you start your framework and then you install your jars in this framework.
Yeah.
So, in one of the jars that is installed there is, for example, declarative services or the CDI implementation.
This is what I meant. So the one dependency in the service registry has specific capabilities, and this is the the component launcher or whatever.
Yeah, and this is not part of the service registry. It's just a module which says, okay, you can register things like a bundle tracker which tells you when a bundle appears or goes away. So, and it is looking for you at new incoming bundles and registers things in the service registry as needed and necessary.
Yeah.
So, but these are two separate parts, basically, which bundles are installed and which services are in the service registry.
So this makes sense. So what it means is now, the core is always starting. So what you get in worst case, you have all the dependencies, but nothing happens. And what can also happen is that a specific bundle starts, and this is the component bundle, and it listens for the spec and implementation pairs. And then you get dependency injection. You can then start CDI or whatever. So then this is clean again. This is what I meant. So that in the service registry, there is a specific component, which is like any other component, except it uses the registry like recursive part, right? It uses the registry to find other components and starts everything, provides lifecycle and so forth.
Yes, so you can easily, also you can roughly say it like this.
So from my understanding, you could actually create like Prometheus exporter. So it will start in the service registry, look for components with specific monitoring annotations, and export then as Prometheus metrics, right, or open metrics format or whatever.
Yes,
or JMX or whatever. I mean, this was just an example. Yeah.
And the nice thing is when you always use the service registry as your interaction point between your modules, you get a lot of neat little things. So you can always register at any time and unregister things in this registry and use this as a marker. So what my initial example with the JAX-RS things, there's also no component and annotation scanning in there. Also, so no class scanning up front. What we are doing is we register JAX-RS resources as services, and there is then the JAX-RS whiteboard, which picks these things up, then scans, then it scans the classes, it gets there, the components, it gets injected, or the services, and then it uses them to provide a JAX-RS endpoint with it.
So what it means, you could actually add additional resources at runtime with new versions.
Exactly. And this is one of the things where really OSGi really kicks in. This is at development time, because you never have to restart anything. Usually, if you work with JAX-RS or servlets, at the moment you add a method, even with the debugger and hot code replacement, you're screwed and need to restart because your debugger tells you, sorry, hot code replacement doesn't work anymore here. With us, it's, you change your code, add a method, add an annotation for, now it should be another content type or producer or provider or whatever. And, as the bundle gets uninstalled, everything gets unloaded, the new bundle gets installed automatically underneath, and, it gets picked up automatically, and you can still work on with what you don't need to restart the whole construct. So this really speeds up development.
Yeah, and this is full cycle, because what we talk about, we are already 80% of implementing an application server, right? This is what the Glassfish and JBoss are doing, because in the Glassfish case, what there was a small bundle called EGB. As I remember, it was 700K. And this, booted the entire EGB container. This was an OSGi bundle, or it is, in Glassfish or Payara. So we are already that far. So this is what actually really full cycle, right? Because this is what I also thought. OSGi is genius just for building application servers, of course. But in your case, you say, okay, why I need application server if I already have OSGi, right? Because if you don't need anything on top if you're using the framework from day one. But another story is, what is also very similar, right, is to Kubernetes, actually, right? But Kubernetes is exactly the same what you created, with far more, ceremony and circus with processes and heavy stuff. And etcd, right, in Kubernetes is, for me, like the service registry in OSGi. But far leaner. I mean, you would save orders of magnitude more resources. Also, your OSGi bundle, in worst case, would consume 500 megs of RAM, and Kubernetes is a gigabyte of resources, right?
Yeah. Also, as far as I seen it in the past, as Kubernetes came up, or before Kubernetes, people started using Docker. And, or as Docker came around, it made it easy to really separate things that had been large before. So then somebody came up, had the idea, hey, we just slap, REST endpoints in between the whole things. And so we can have our business modules. So we can have different teams use whatever, if they want to use Node.js or whatever in there, what was a nice idea. And years back in a project, we started looking, everybody started looking into using, it was pre-Kubernetes, or was Kubernetes, that was sort of one of the first versions of Kubernetes that had been out. And everybody was, whoa, yeah, that's totally cool. And I was looking at it for like, yeah, it's the same thing we are doing for years now. And after 2 months, everybody thought that he was the expert and said, yeah, here I can have my things there and here. And I always realized nobody really saw the downside of the whole thing at first, because everybody was excited that they now could package things up in the way they liked and have to separate it. But for one, you always bought the network delay in your communication. You moved your application orchestration and made it somebody else's problem. And at the beginning, it was like nobody really cared about the life cycle you have inside your Docker container. Because at the time, we had been building a search server using Lucene. And when the whole thing started, it took like 20 minutes to build its index. So, meaning if somebody threw this in a Kubernetes container, somebody else would get injected, hey, your search server is now available. Here are here's where you can find it. But the search server itself wouldn't be available for like 20 minutes. So nobody really took care about this life cycle and cared about it. So then you would have needed to implement manually to pull and everything. And this is something which always OSGi addressed from the start. And for me, Kubernetes had been a big overblown, unnecessary part everybody was just jumping to right now because they haven't seen the possibility before.
Jumping. I mean, I made different observations. So I was one of the first Docker users, and the reason for that, I even used Docker before it was consistent. So I had problems with the file system at the beginning. And the reason was I always had my own servers, and with Docker I saw the first time the possibility to have a proper backup, because I say, okay, I can have bare metal server, then I can just put my Docker containers, and I don't have to to document what I actually did with all the systemd on whatever was necessary for firewalls, because with Docker it was a lot simpler. The problem with Docker, of course, always had were the ports. So I didn't have that many applications, but you get ports collisions. And what Kubernetes solved is what Docker also solved. Docker did the Docker networking, but it never took off. But what Kubernetes did, you never had the problem with the ports again. So it virtualized the network. So I would say the network virtualization was very pragmatic in Kubernetes case. But on conferences, I was completely confused because developers never talk about that. So it was more about microservices and scalability and resilience and fault tolerance. And this, for me, if you look at the Kubernetes, all the YAMLs you need to deploy a simple thing is crazy. So I would even prefer manifest MF in OSGi before I have to edit all the YAMLs. So it means the Kubernetes solved actually a problem well with the IP addresses. So every service got their own IP address and the ports, but and it came with a huge overhead. So and the overhead is okay if the deployments are larger. Or this is what I also forgot to mention. I never run a small microservice in a Docker. It was more like we had apps in a Docker. So it was far larger. We had so in my case still small wars. But there was like a team, 5 to 10 developers shipped a microservice, I call it, because it was still small, and this was a part of the Docker. So a larger applications, maybe we had, at most 10 microservices, but there were more like 10 apps working together. So this would be your project with 100 developers, like 10 such a microservices. So, and so what it means is in Payara, or back then Whitefly or Open Liberty case, we had actually 10 OSGi runtimes. Packaged in things. So with OSGi, it's a different story now in the linear world. What you could do is you can consider having the OSGi server as Kubernetes. You say, okay, the isolation is good enough, so I can have I can deploy multiple apps in a single core, and development experience is great. And at runtime, I can save resources, actually, right? And this is always like a tenant isolation, so this would be your decision, Of course, I can isolate everything still with Docker, but I don't have to. So if it's good enough, I could have, one, how to call it, like a container, which provides runtime for services.
Yes. So to pick your things apart, so first of all, the thing you said, Docker and Kubernetes solve, this is also where I like it and where we use it as well. Because usually when we are done, we provide to our customers one or more Docker containers. So with everything in there. So because it's ready to install, just use it and don't take care about anything. Maybe set a few properties around it. The other part is also true. You can have also multiple applications in one big OSGi container, so to speak. Because the reason is the way OSGi handles modules is basically the textbook definition how modules should look like. And if these modules run at the same virtual machine, the same bare metal or Docker container, doesn't really matter. So the concepts stay the same or stay similar. So, and especially what you said, that there are a few approaches. The one thing is we have the so-called remote service specification. So a remote service is simply a distributed, as that you can have multiple OSGi frameworks running with multiple containers. And you can declare my service should also be available to the outside world. So, and then it's automatically announced to other containers, which are also connected to the system, and get imported as needed. So, which means for me as a developer, I work against my interface. And if the implementation is living in my JVM or somewhere else, doesn't matter to me. Everything else is taken care of.
Like a proxy, right?
Like a proxy, there is a proxy will be built in between. There are ways to transport the things like via MQTT, via a couple of different transport mechanisms, and so on. And the nice thing then is the packaging around it doesn't really matter. For you as a developer, you just say, I want my CSV importer or exporter. And this is what you are doing. And then at some other point, somebody else comes around and says, okay, now I take my modules and either put it all in one big deployment. And at a certain point, you can see, the CSV importer or exporter, this is the weak part. So this needs scaling. And then you can move this part out, for example, if you want at runtime, and throw it in another remote services, scale it there. On maybe a faster machine or whatever you're doing there.
Failover, right? Scaling, I would say scaling is, I mean, if you look at the cloud, most services are running on a fraction of a CPU. It's not like, this is
scaling, or if it makes sense to sometimes you will have a requirement say, hey, this is, for example, running an index. This needs a faster hard disk.
Yeah, exactly.
Or things like where you need better GPU than a CPU and things like this. And this is where you can then, it really kicks in. And then you can distribute your things as you want. For you as a developer, it doesn't matter how these things are working together and where they are. Yes, you get latency and things then in there as well. Naturally, so there's a limit to the whole thing until you need to think about it. But how you package and deploy your bundles and your modules and how you curate them doesn't really matter anymore. And so this is the one way of doing it. And the other thing is you could also basically use it, and there are things out there that do this to orchestrate your containers, because a container or an application can also be like a bundle. It has a life cycle. It has things it can do. It has a contract. What can it do? What can't it do? If you as a user, your database, for example. So you can basically
But this is going to be too long if we start with database right now. Do we have a lot to cover still, OSGi? Did we cover, everything? No, we have still things to cover.
Yeah, we now covered the basics of OSGi.
Very good. So what I would suggest, we meet again and have a deeper discussion now about the more exciting OSGi stuff, because now we have common understanding what OSGi is, modern OSGi, and then we can cover the more exciting OSGi in the clouds, let's say.
Yeah, I'd love to.
Perfect. So where people can find you with data in motion, or your Twitter account?
You can find me at datainmotion.com, just as this, or in a couple of different open source projects like the OSGi projects in Eclipse. There we can be found. The BND Tools projects, we can be found there as well as committers. Also on Gecko projects on GitHub. And on GitLab, where we have our open source things, where we use the model-driven part together with OSGi. And I can send you a few links so we can put.
Perfect. Yeah, just do it. This will be greatly simplify, my show notes editing work. Okay, thank you. See you next time.
Before you sign off, have I convinced you to maybe use OSGi at some point?
I always use it. So what I actually always search for is a pragmatic way of using this, and I use always OSGi behind the scenes with with Glassfish, Whitefly, and so forth. In my current project, the services are too small, but I mean, one of the first project, actually, this was interesting. Volkswagen asked me about OSGi. And this is like, Sun embedded server came out. This was exactly right. This was very beginning of OSGi. This was the Sun book. So I remember it was around 2000. And we look at that. So I always stick with OSGi. What I didn't like, there was a period where it was like too much hype and no one, like OSGi back then was like Kubernetes right now, I would say, or Kubernetes 2 years ago. So this was like, the same craziness. So I asked, why we need OSGi, and the answer was because of modularization. And this is what I don't like. I don't care about modularization. I would like to build apps which are understandable, right? If you can explain clearly what the benefits are. I mean, this is another tool, and I'm really interested in it, right? And for instance, Open Liberty. It is excellent. It works perfectly. Why? Because of OSGi. So I mean, there is no question about that, right? So and this was like just I was just curious how you react. So this was the intro. This was,
yeah, no problem.
So you don't have to convince me because I knew it working well, but it was not always. It was often misused in my projects,
Yes.
People wanted to use, OSGi to have modules. And I asked why you need modules, and no one knew, because it was fancy to have a module. So, okay, then I can create for you 20 modules. And if you are happy, then the project is over, right? So this was
and this is always the wrong reason to use anything, just because it's there, and because the reason for it is it itself. So
yeah, perfect. So see you next time to talk more about the specific stuff or the exciting OSGi stuff.
Yeah, thank you very much.